Chapter 10, Problem 29. A playground merry-go-round has a radius of 2.4 meters and a moment of inertia 2100 kilograms meters squared about a vertical axle through its center, and it turns with negligible friction. A child applies an 18 Newton force tangentially to the edge of the merry-go-round for 15 seconds. If the merry-go-round is initially at rest, what is its angular speed after this 15 after this 15-second interval? B, how much work did the child do on the merry-go-round? And C, what is the average power supplied by the child? So we're going to use a couple of equations here. We have our torque is equal to inertia times our angular velocity. We have our torque again times force applied is equal to inertia times, well, our torque is essentially equal to radius times, or torque times force. Then we have that our angular, then we can set it equal to our angular velocity. So our angular velocity is equal to 2.4 times 18 or 2100, which gives us 0.0205 radians per second. So we use this equation right here for a rotational kinematic equation in order to, so we have our initial angular velocity is omega 0, and then this is our final velocity times our angular, I think it's acceleration, angular, I think I messed that up, so angular acceleration times time. So we again can plug in the numbers that we have, and so we plug in 0 for our initial angular velocity, because at the beginning there wasn't any speed, plus 0.0205, oh no, that is right, that is velocity again, times 15 for time, so seconds, so that gives us 0.309 radians per second for A. For B, our angular displacement, we find that angular displacement is equal to our initial angular velocity times time plus 1/2 angular velocity times time squared. And so we can plug in the numbers again, so we get 0 plus 1/2 times our angular velocity times 15 squared, which gives us 2.31 radians. So then we can use that later on, or in this next part, which is our work is equal to torque times the angular displacement. So again, our torque is equal to torque times force times angular displacement. So work is equal to 2.4 times 18 times 2.31, which equals 100 joules. So then we find the power supplied by the child by taking the work over time, which is 100 over 15, which gives us 6.67 watts.